Review for Geometry, Topic 7, Exam, Section 1. Before we look at the problems that are on the exam, let's first look at the formulas that you're going to need to know for Section 1. First of all, there's the angle relationships in circles. The easiest way to look at this is to just analyze where are the vertices of the angle, all right? So if the vertex of the angle is on a circle, if the vertex is on a circle, then the measure of the angle is going to be half the measure of its intercepted arc. So here's this angle, the vertex is on the circle, here's the intercepted arc. The intercepted arc is 120, so the measure of the angle is half of that, 60. Here, the vertex of the angle is on the circle. The intercepted arc is 200, so the measure of this angle is half of 200, which is 100. If the vertex is inside a circle, if it's inside a circle, then the measure of these angles is going to be half the sum of the intercepted arcs. So you got to add up the intercepted arcs and get half of that. Here you add 44 plus 86, get half of it, and it gives you 65 degrees. And finally, if the vertex is outside a circle, if the vertex of the angle is outside of a circle, then the measure of the angle is half the difference of the measure of its intercepted arc. So for angle 1 here, the measure of its angle would be half the difference. You got to subtract of the two intercepted arcs. So you would do 202 minus 78, and whatever it gives you, get half of that. Here's another easy formula or relationship that you need to know, which is the inscribed quadrilateral theorem. Whenever you have a quadrilateral inscribed in a circle, inscribed means that all the vertices are on the circle. Then opposite angles are supplementary. So this angle is supplementary with this one, and this angle is supplementary with this one. That's very simple. These are basic formulas from middle school. So first of all, the diameter. This is the diameter. It's a chord that goes from one end of the circle to the other, going through the center of the circle. And the radius is the distance from the center to the circle. The circumference is the distance around the outside of the circle. All right, so the circumference has two formulas, 2 times pi times radius, or pi times diameter. Area is the space inside of the circle, okay? Area is the space inside. To get the area of a circle, you got to do pi times radius squared. The equation of a circle in standard form, make sure you understand how to use this equation. Remember that when you have the equation of a circle in standard form, the center of the circle is h comma k, and r is the radius. All right, I'll do examples with that later on. And the last formulas that I need to go over are two formulas that were not covered in the book at all. These are completely brand new to you. They're on the test, and when we get to those problems, I'll explain them, all right? But here are the two formulas. And we did go over arc length, we did go over area of a sector, but these formulas, you only use them when the central angle is in radians, which we'll look at two problems in section 1 regarding this. So when the central angle is in radians, as opposed to degrees, you got to use these formulas. All right, so section 1 has 13 questions. Let's look at our first question. Quadrilateral ABCD is inscribed in the circle pictured. Tiffany wants to prove the theorem that says that the measure of the quadrilateral's opposite angles add up to 180 degrees. She knows that the measure of angle A is half the measure of arc BCD. All right, the measure of angle A is half the measure of this arc right here, arc BCD, which is correct. And that the measure of angle C is half the measure of arc BAD. Which of the following is an appropriate step to prove that which of the following is an appropriate step to prove that the measure of angle A plus the measure of angle C equals 180 degrees? Can we assume that the measure of arcs BCD and BAD add up to 360. BCD and BAD. Yes, together they form a circle. So yes, we could assume that they add up to 360. Can we assume that the measure of arc BCD is 150 and the measure of arc BAD is 210? I mean, no, we can't assume that. We don't know how much. I mean, it's possible, but why would we assume that? They don't necessarily have to be those measurements. All right, so no, you would not assume that. Because remember, what you're trying to do, it says here, which of the following is an appropriate step to prove that the measure of angle A plus the measure of angle C equals 180? So if you were doing a proof, you wouldn't include this in the proof because we don't know what those arcs measure. They might measure that, but we don't know that. So no, you wouldn't assume that. Okay, how about the third one? Would you use this in a proof to prove this? Substitute 1/2 times the measure of angle C for the measure of arc BAD. Here's arc BAD. Would you substitute for the measure of this arc? Would you substitute 1/2 times the measure of angle C? That's wrong. It should be 2 times the measure of angle C. If you don't get what that means, let's say I make up. Let me just make up a number. If this angle is 100 degrees, let's say, then this arc would have to measure double that, 200. And according to what it says here, they're saying that if this is 100 degrees, arc BAD would be half of 100, 50 degrees. That's wrong. That's incorrect. Okay? So no, that's incorrect. And the last one, substitute 2 times the measure of angle A for the measure of arc BCD. Yes, that one is correct. All right? If you multiply the measure of angle A times 2, that'll give you the measure of arc BCD. All right, so that last one is correct. Okay, for the next question, I just want to review real quick this video that shows what a radian is, because we're going to need it on this next question. So remember that a radian is when you take the radius of a circle and wrap it around so that the length of this arc is the same as the length of the radius. All right, let me play the video so that to refresh your memory. So you take the radius and wrap it around the circle so that the length of that arc is the same as the radius, and that makes 1 radian. Again, the length of the arc equals the length of the radius, and that makes 1 radian. With that in mind, let's look at this question, which says, okay, I know it looks complicated, but let me explain. And again, this is on the test. I'm putting it on the review because it's on the test. In the given image, theta 1 equals theta 2. Basically, that means that the measure of this angle equals the measure of this angle. Okay? The measures of the angles are equal. And the angles are measured in radians. This is important. The angles are measured in radians. So which of these must be true? Okay, so if the angles are measured in radian, I think it's easiest to explain this one if I show you the correct answer so that I can talk about why it's correct. All right. The correct answer is D. Let's look at it a second. All right, so the correct answer is saying that if I take this arc divided by this radius, it'll equal this arc divided by this radius, and that'll equal the measure of these angles. Okay, so let me put some random numbers here to help it make sense, because I know this is a little bit confusing, maybe a lot confusing when you're seeing it for the first time. All right, so let me put a random number. Let's say that this arc is 5 and this radius is 5. And let's say this arc is, I don't know, 8 and this radius is 8. So the relationship, if I plug in those numbers for what it says here in the correct answer, I'd be saying that 5 over 5 equals 8 over 8 equals 1 radian. Okay, again, this is the correct answer. Do I like this question on this test? Absolutely not. But it's on the test. We got to deal with it. I think this is the easiest way to explain it, without further complicating it. So again, I would look at this before the exam, because if you look at those answers, they're pretty scrambled, and you don't want to make the wrong choice there. All right. All right. Let's move on. Question number 3. The drawing below shows circle B and circle E. The measure of arc AC equals the measure of arc DF. What that means is, for example, let's say arc AC is 80 degrees. This is just a random number that I'm putting there. Then arc DF would also be 80 degrees, all right? However, now look what it says. The length, the measure is different from the length. The length is how many units this is, how many units long, and how many units long this arc is. The length of arc AC is 4 times the length of arc DF. So the length of this arc is 4 times the length of this arc. Which equation best describes the relationship between BC and EF? Okay, this one's pretty straightforward. If the length of this arc is 4 times the length of this arc, then the length of this radius will also be 4 times the length of this radius. Again, I would review that before the test just to make sure that you got it. All right, question number 4. Gael wants to use a dissection argument to justify the formula for the area of a circle. She dissects the circle. I spelled that wrong, I think. She dissects the circle into congruent sectors and reassembles the sectors as a parallelogram-like figure. Okay, Gael knows that as the number of sectors of the circle increases, the reassembled figure becomes closer and closer to an actual parallelogram so that it can be used to determine the area of the circle. Determine the value of each characteristic of the parallelogram in the table below. Select the best value for each characteristic. Okay, look, first of all, let me direct your attention down here to what I wrote. Important, there are 2 questions on section 1 on this concept. And I'm only putting this one question in the review, but I'm going to explain everything in this one question. And right now I can't remember, but it's possible that it pops up in section 2 as well. So this is important to know. And I believe this also comes out in the geometry EOC. All right. I explained it when we saw it in one of the chapters for this topic. I can't remember which chapter it was right now, but let me explain it again. So basically, the concept is this. If you divide the circle into these pieces and rearrange it into a parallelogram, it comes very close, like getting the area of this parallelogram will come very close to matching the area of this circle. The more pieces you divide it into, the more accurate the area that you get will be to match the area of the circle. Okay, so let me explain a couple things. First of all, the height of this parallelogram. The height of this parallelogram is not exactly, but close to this line, more or less. And what is this red line? This red line is this right here. It's the radius of the circle. All right, that's very important. So the height of the parallelogram is best represented by the radius. That's your first answer here. The radius of the circle. That's the height of the parallelogram, the radius of the circle. Okay, next part is look at the base of this parallelogram. It's made up of the bottom portion of 1, 2, 3, 4 of these little triangle-like figures or pie-like figures. All right, so the bottom is made up of 4. Let me say that better. The base of the parallelogram is made up of the bottom portion of 4 little triangle-type figures. All right, 4, right? So now look at the circle. 1, 2, 3, 4. All right, those are 4 of the bottom portion of these shapes. That's half of the circumference of the circle. Half of the circumference of the circle. Look what I'm writing. Half of the circumference. What's the formula for the circumference of a circle? 2 pi r. All right. If I multiply 1/2 times 2 pi r, the 2's cancel out, and you're left with just this, pi r. That's why the base of the parallelogram is pi r, because it's half of the circumference of the circle. Okay, now the last one asks for the area of the parallelogram. All right, which of these best represents the area of the parallelogram? So let's look back here. The base of the parallelogram is pi r. The height of the parallelogram, I said, was the radius. And how do you get the area of a parallelogram? By multiplying base times height. So if I multiply this base times this height, I'm going to get pi r to the second power, which if you have your formulas memorized, that's also the formula to get the area of a circle. All right, so make sure you understand that, because that comes out on at least 2 questions on the exam. Moving on. Which angles are supplementary in the figure below? This is too easy. You cannot get this wrong because it's too simple. I went over it at the beginning of this review. Opposite angles, when you have a quadrilateral inscribed in a circle, opposite angles are supplementary. So angle A and C are supplementary, and angles B and D are supplementary. Okay, now we've gotten to the part where there's something that was not in the book at all, and the next 2 questions are dealing with it. So look what I wrote. The next question, I should have written questions because there's 2 of them. The next questions were not covered at all in the book, but you need to get it right anyways. Hashtag no mercy. You will need the following formulas. Let's look at the formulas, all right? And I don't want to hear any excuses, all right? Yeah, it wasn't in the book, but I'm going over it right now. All you got to do is obey whatever the formula tells you to do. That's how formulas work. You just plug in the values that they ask for, and they give you the answer when you do the calculations, of course. All right, so let's look at it. We use these formulas when the central angle is in radians. The reason these formulas were not in the book is because in the book, when we did arc length, all the central angles were in degrees. And in the book, when we did the area of a sector, all the central angle were in degrees. Why did they decide to put this in the test? I really have no idea, but it's in there, right? So first of all, the formula for arc length, all you got to do is this. You just multiply the radius times the measure of the central angle, whatever it is. That symbol for theta is the measure of the central angle when it's in radians. So again, all I'm going to do is multiply whatever the radius is times the measure of the central angle, which is in radians. And I'm using this formula for arc length. And for the area of a sector, the formula is 1/2 times radius squared times the measure of the central angle. That's what this is, the measure of the central angle when it's in radians. All right? And I put the formula for area of a circle, but it's the same as always, so that's not a big deal. But you need it on the question also. So let's look at the question. I put the formulas right here, okay? So we could have them right there. All right, so it says, I wrote, this was not in the book. By the way, I put 6A because I'm going to have a 6B, 6C, and 6D. I put four examples on this question so that you could look at it 4 times, practice it if you want to, and make sure you understand it. All right, so the circle shown has a radius of 6. All right, the radius here is 6. The central angle A of the sector is 3/4 pi radians. So that's the measure of the central angle, 3/4 pi radians, and the arc length is represented by B. So we got to find these 3 things. Find the arc length, find the area of the sector, and find the area of the circle. Let's take one at a time. First, find the arc length. So I look at my formula for finding the arc length when the measure of the central angle is in radians. And the formula tells me I got to get the radius and multiply it times whatever the measure of the central angle is. Okay, it says here my radius is 6 and the measure of the central angle is 3/4 pi radians. So that's what I'm multiplying right here, 6 times 3/4 pi. You're going to multiply this and just leave pi alone. Pi stays in your answer. You're writing your answer as a multiple of pi. All right, so pi, you just leave it there. So basically, all you got to do is multiply 6 times 3/4. 6 times 3/4 is 18/4. And when I simplify that fraction, I get 9/2. And there's my answer for the arc length, 9/2 pi. Area of a sector. Okay, to get the area of a sector, let me look at the formula for area of a sector when the central angle is in radians. The formula says I got to multiply 1/2 times radius squared times theta, which is the central angle in radians. So let me plug in the values. Let me substitute. 1/2 times the radius is 6 to the second power, I got to do. And the measure of the central angle is 3 over 4 pi. So follow the order of operations. First, I got to do the exponent. 6 to the second power is 36. Half of 36 is 18. And 18 times 3 over 4 pi will give me 64 over 4 pi. And when I divide 64 by 4 to simplify, I get 16 pi. And the last one, the area of a circle, which is nothing new. All right, here's the formula for the area of a circle. I got to multiply pi times radius squared. The only thing that I would say is that I got to point out is that they're leaving the answer as a multiple of pi. They're leaving pi in the answer. So you just do 6 to the second power, which is 36, and leave your answer as 36 pi. All right, I have 3 other examples here that you need to look at. It's the same thing. All I'm doing is changing either what the radius is or changing what the measure of the central angle is for all of them. All right, so make sure you look at that. 6C and 6D so that you can get the hang of it. All right, moving on. Okay, so here it says Jose is studying the circle below. He wrote down the following steps. All right, step 1, step 2, step 3. What did Jose derive? If you're like, what does that word mean? Derive means obtain by a sequence of logical steps. In other words, what did Jose get here? By doing these steps to come to this conclusion, what is it that Jose got? That's what derive means. All right, so look at what it says there. And I don't know, but that looks pretty familiar. It looks a lot like what it says right here for arc length. Look at the formula. All right, so that's what it is. Jose got the formula for arc length when the measure of the central angle is in radians. Again, do I like this question? No, I don't like this question. I think there's a lot of bad questions on this exam. But it's on the exam, and I'm basically telling you the answer. So how many of you are going to mark this wrong because you don't bother looking at the review or studying ahead of time? Anyways, that's what he got. He got the formula for arc length when the central angle is in radians. Okay, 8a. In the figure given below, AB is a diameter of the circle. So AB is a diameter of the circle with center O. If the measure of angle ABC is 40 degrees, so if the measure of this angle right here is 40 degrees, and the measure of angle CAD is 120 degrees, what is the measure of angle BAD? BAD. Okay, so if the measure of angle ABC is 40 degrees, what is the measure of this arc right here? If this angle is 40, this arc has to be 80 degrees. And if the measure of angle CAD is 120, all right, 120, that means the arc that it's intercepting, which is all of this, has to be double 120. It would have to be 240. Okay, now a circle is always 360 degrees. So if this arc is 80 and this arc is 240, 240 plus 80 is going to give me 320. All right, so that means that this remaining portion, this portion right here, has to be 360 minus 320, which will give me 40 degrees. So this arc is 40 degrees. Now let me erase everything except for the information that this arc is 40 degrees. All right, this arc right here is 40 degrees. And the question was, what is the measure of angle B? Wait a minute, did I make a mistake? Oh, yeah, okay, I got confused for a second, right? One more thing I forgot to do. If this is the diameter, right, or let me say that better. If this is a diameter, that means that this is a semicircle. A semicircle is 180 degrees. So if this portion is 40 degrees, the remaining portion has to be 180 minus 40, which is 140. All right? So this arc right here is 140 degrees. That means that the measure of angle BAD has to be half of 140 degrees, which would be 70 degrees. All right? So angle BAD is going to be 70 degrees. It's not difficult, but you want to be sure that it's not difficult, and there's probably more than one way to get the right answer, but you want to make sure you're familiar with how to get it before the test. All right? And I put another example that you could practice with, so you could use that when you're studying to practice. I do the exact same steps, and there's the explanation. For the sake of time, I'm going to go on to the next one to not make the review too long. Okay, question 9a. If arc WX is 30 degrees and arc YZ is 56 degrees, find the measure of angle 3. Okay, I went over this formula at the beginning of the lesson. When the vertex is inside of a circle, then the measure of the angles formed, in this case the measure of angle 3, is going to equal half of the sum of the intercepted arcs. So half of 30 plus 56. So that's going to be half of 86, which is going to be 43 degrees. So the measure of angle 3 is going to be 43 degrees. Oops. In case I went too fast there, there's the explanation. 9b is same exact question. I just changed the numbers in case you want to practice or see another example explaining the same concept. Question number 10. Which equation best represents circle A? Okay, so first of all, what's the center of the circle? The center of the circle is 5, 1. And what's the radius? All right, the radius is where we find our issue. Okay, the radius is close to 8, but not exactly 8. It's between, I'm sorry, I'm looking at the wrong thing. The radius is close to 1, 2, 3. It's close to 3, but not exactly 3. Because remember, the radius is the distance from the center of the circle to the circle. And if you look at it, the distance from A to B, 1, 2, it's in the middle. And that's how it is on the test, by the way. That's why I put this example like this. It's between 2 and 3, but closer to 3. All right? So let's look at the answer choices. First of all, we could eliminate 2 wrong answers just by knowing how to correctly write the center of the circle. So if the center of the circle is at 5, 1, when you write that in the equation of a circle in standard form, it would be x minus 5 to the second power plus y minus 1 to the second power. Okay? Because remember, the formula is x minus h to the second power plus y minus k to the second power equals the radius squared. You need to know that formula. Obviously, it's on the review, but you need to understand it. So if this is the center, this is h, and this is k. So if I know that part, I could right away eliminate these 2 wrong answers because the center is written incorrectly. It's got to be between these 2 answers. Okay, now look at the radius. If you know that in the equation of a circle in standard form, what you're writing over here is the radius to the second power. Okay, and the radius here is close to 3, but it's greater than 2, but less than 3. All right, greater than 2, but less than 3. So look at what I'm going to do, okay? If the radius were 2, I would need to have a 4. Where could I write this? If the radius were 2, then this number would be a 4, right? And if the radius were 3, which it's not, this number would be a 9. So out of these 2 possibilities, because if you look at the radius, it's closer to being 3. The radius is almost 3. It's almost 9. So which is a better number to put back here, 3 or 7? I said that if the radius were 2, this number would have to be 4. And if the radius were 3, it would have to be 9. It's got to be between those two. 3 is less than 4, so it can't be that one. The correct answer has to be letter D. All right, that would be the most correct answer there, because the radius has to be greater than 2 but less than 3. All right, here's, okay, I thought I put another example like that, but I didn't. All right, 11A, circle A is defined. You know what, let me pause the video 1 second because I have a class about to start and I'm still recording this video. Give me 1 second here, guys. Okay, question 11A. Circle A is defined as, and they write the equation of a circle in standard form, and circle B is defined as this. Which transformation of circle A shows that circle B is similar? Okay, so look, before we even approach this, let's identify the center and the radius of each circle, and then we can look at the answers, right? So, and by the way, if you don't know how to do this, this is easy. Like, you need to learn this because it's very simple. It's not difficult at all. And I'm telling you, it's going to come up a lot on the geometry EOC. All right, so for circle A, let me write circle A. Circle A. All right, the center is just, you get these numbers, and it's going to be with the opposite signs that are here. So it's going to be, the center is going to be -4, +6. Okay, and the radius is always going to be the square root of the number that's here. So the radius is 5. All right, so that's circle A. Sorry, it came out a little messy there. Circle B. All right, the center is going to be -1, -3, and the radius is 4. Okay, so if you look at the questions, they're talking about, oh, circle A is translated in this direction or that direction. So let's use this point. If we're at -4, +6, and we move the center of the circle to -1, -3, how is that translating how is that translating that point? All right, if we go from -4, +6 to -1, -3. All right, so let's analyze one coordinate at a time. Look at the x coordinate. The x coordinate is going from -4 to -1. Is that moving to the left or to the right? Okay, I'm kind of in a hurry, but if you're at -4 and you move it to -1, that's moving it 3 units to the right. All right, so just understanding that, we could eliminate 2 wrong answers. I could eliminate B and D. All right, because I gotta be translating it right 3 units. Okay. Now they both say that it's going down 9 units, which is correct. So let's move on because it's moving down 9 units as well if you look at the y coordinate. Okay, now the radius went from 5 to 4. The radius got smaller. So is it being enlarged or reduced? Okay, enlarged, let me go over this because there'll always be someone to ask me. Enlarged means to make bigger, reduced means to make smaller. So it's being reduced. So obviously the correct answer would be C. And just to take it one step further, if you go from 5 to 4, that means you're multiplying it by 4 over 5 so that these 5s cancel out and your answer would be 4, which is what it says here, that you're multiplying by a scale factor of 4 over 5. All right, so the correct answer is C. All right, here's another example that you could look at as well. Follow the same process. First, find the center of circle A and the center of circle B so that you can analyze how it's moving and then compare their radiuses. All right, in this one, the correct answer is D. If when you're reviewing, you don't get it or you have a question, you could always send me a screenshot on Remind and I'll get back to you and I'll explain it to you further if you need it. Okay, question number 12, Skippy. Skippy's a former student of mine. He's a senior now. That's not his real name, though. That's just a nickname. Skippy drew the diagram below. The inner circle has a radius of 3 units. The outer circle has a radius of 7 units. Skippy says the two circles are similar. First of all circles are similar, period. All circles are similar. Always. It doesn't matter. If you have a circle, any two circles, they're all similar. Okay, so which statement best explains whether Skippy is correct and why? So first of all, you can only choose from the questions that say that he is correct. Because like I just said, let me write it somewhere. All circles are similar. Sorry, I'm writing slow because I could tell the pen I used to write is starting to mess up. Are similar. And just for emphasis, period, since I know you guys like to say that. Period. All right, all circles are similar. So it says here that Skippy says that the two circles are similar. Is he correct? Yes or no? Okay, right off the bat, yes, he's correct. Because all circles are similar. Now we got to choose between the second part. Is he correct because the inner circle has the same center as the outer circle? Well, I just said that all circles are similar, period. That means that if I got this circle with this center, it's similar to this circle with this other center over here. So the center doesn't make a difference if all circles are similar. So it's not that one. It has to be D. He is correct because the inner circle is a dilation of the outer circle. All right? The smaller circle, you're making a dilation to create the bigger circle. It has nothing to do with whether or not they have the same center. So if I have like these two circles here, this circle, if you dilate it, it'll become this circle. It doesn't matter. They'll be similar. It doesn't matter that they have different centers. Okay? All right, guys. So that concludes the review for Section 1 of your exam. Next class, we'll review for Section 2. Make sure to look at this ahead of time. There are so many people. A lot of you guys did good on the previous exam, but a lot of you guys did not do good only because you don't take the time to look at the review ahead of time, and then you make silly mistakes on the exam. Especially when there's a lot of questions where I'm basically giving you the answer and you guys are still choosing the wrong answer. So that's not a math issue. That's an issue that you're having that you need to fix. All right, because the teacher is giving you more than enough help to get a good grade. And remember that I count these tests a lot. All right, guys, that's it for today. Hope you guys have a great rest of your day, and I'll see you guys next class.